Did you guys see this building before? It's not supposed to be. And then, yeah, it's right, just, yeah, everyone can hear you fine here, but always hold it up close like this because then the people on online can then hear you. Okay, okay. And I'll just let you quickly flag you guys. Okay, team, you can go ahead and get started.
Hello, everyone. We are Team Darwin's Workforce, and we are very much excited for this DA and capstone presentation. The title of our project is Geographically Contextual Knowledge Worker Cost. What that means is, what is the total cost of employing a knowledge worker based on different geographical factors like location-based salary differences, cost of living, and also the office space expense. Now let's look into the project. Before we dive into our project, I would like to take a moment to acknowledge our professor, Dr. Rollins, and for her consistent feedback and support. And also, we would like to thank Dr. Kurt Rasmussen for his valuable industry experience, which helped us shape our project. We sincerely thank both of them for their continuous mentorship. Thank you. Meet the minds behind the project. I'm Nikhil Reddy, the Scrum Master, and we have Rohit, the Product Owner, and we have 4 developers, Akash, Mogana, Pooja, and Kirti. This is what we'll be presenting you today. We'll start with the problem statement and domain context. We'll walk you through the data sources and the consolidation process, and then we'll showcase the findings, methodologies, and then we'll wrap it up with the project demonstration video. Let's look at the problem statement. As we all know that during the COVID, many of the knowledge workers have transitioned to remote work. Back then, it was necessary, but right now we are in the post-pandemic era. Many of the government agencies and businesses are rethinking of their workplace policies. Some say that remote workers are less efficient, while others say that it saves upon cost and as well as has more flexibility. But here, the actual question is, what is the actual cost difference between maintaining in-office workspaces or letting the employees to work remotely? To analyze this question, we have considered 3 core evaluation factors, which are the workforce management, how does the job structure affects the performance and as well as efficiency, and also the financial impact, what is the actual cost difference of having the office spaces in both private and federal sectors. And also the geographical flexibility, like how does a geographic location affects the salaries, cost of living, and as well as the job distribution. Now I will pass it on to Rohit. He will walk you through the rest.
Hello, I'm Rohit. Now let's discuss why it is important, because it may lead to 3 main factors, which is the financial impact, such as the poor cost planning leads to overspending of the amount. It may affect the business performance also, where inefficiencies formed makes less profits and more losses. And also the cost variations is very important for both government agencies to, if they want to shift to remote area, to reduce their expenses and maximize the efficiencies. And first we'll define what is knowledge workers. Knowledge workers are the workers, they are actually the non-routine problem solving workers who require both convergent and divergent thinking. Some of the examples are IT professionals, academic journalists, and lawyers. In this project, we have considered the 2 major roles. One is the Federal Office of Personnel Management knowledge worker roles, and is the private sector ONET knowledge worker roles. You can see there is the 8 major roles here, but these are not only the roles which we have taken. We have considered other roles also that will be discussed. While analyzing, we came to know some key cost considerations, particularly in the salary, which we found between private versus federal sectors in terms of location and pay, and also in terms of utilities where per employee cost matters a lot. Next slide. Our project goal is to initially develop a tool to validate and compare the cost of remote office workers and in-office workers in a brief manner, and also to create an visualization map that can help the business organizations to analyze those costs and prepare a better decisions for planning in the future. Next slide, please. In this implementation, we have done it in the 3 phases. Initially, we have collected the workforce data and other data from trusted sources like BLS, ONET, and also job postings to make better deep analysis. Secondly, we have analyzed it using the machine learning models, and also to identify any key cost factors coming, and also to identify any trends to between remote and in-office workers. And also finally, we have finally we have compared those results with known parameters, and also we have utilized the visualizations very well to validate the findings. The next will be covered by teammate Pooja.
Thank you, Rohit. Good afternoon, everyone. My name is Pooja Kawati. To approach our project, we have followed a structured and data-driven methodology. Initially, we began with data collection, where we gathered our data of workforce costs from authoritative sources like BLS and Google Job Search data such as Glassdoor, Indeed, and also LinkedIn. During the data pre-processing, we have cleaned and transformed the raw data into formatted analysis. And following this, we have gone through model selection, where we have implemented advanced machine learning algorithm and spatial analysis techniques. Then using geospatial analysis, we have visualized distribution of remote and in-office jobs across United States using interactive maps and clustering methods. Finally, for the evaluation phase, we have compared sector-specific remote work trends and also cost implications by referencing both private and federal industry benchmarks. For the datasets overview, we have collected multiple various datasets because we have gone through OEWS ONET for the salary and wage data, which has different job roles and locations. Then we have scraped the data to understand the remote versus in-office availability and benefits. Then we have used Octopus to extract HTML data for through online platforms for structured tables. Then we have considered office market data and remote work expenses. In the office market data, we have rent trends, cost, and vacancy rates, and also commute cost. In the remote work expenses, we have considered electricity cost, internet cost, and also other miscellaneous across the states. For the web scraping component, we have used automation tools to extract large amounts of data. The data retrieved was unstructured, so we have transformed it into structured CSV or JSON files. This structured data was very much useful for us for market analysis and also financial comparisons. The tools which were used were Beautiful Soup, Scrapy, and Selenium, which were used to automate the process, and also the extraction made very much scalable and efficient. So after collecting all the data, we consolidated into a structured format to have a clear view of private and federal job sector roles. By taking OEWS and scrape data, we have merged them into wages data, which has job title, city, status, and also the mean wage. Then we have integrated it with the office space cost, commute cost. By this, we got our office cost data, which has rent per square feet, annual commute cost. And then with the remote expenses, which has internet cost, electricity price, and also average internet monthly payment, we finally have our final data sets, which has calculated fields such as total in-office salary, total remote salary, remote work expenses, and also in-office expenses. This data set consolidation helped us to get accurate modeling for our final results. Thank you. My teammate Akash will be continuing with the project.
Hello, everyone. Got it. Hello, everyone. So what is the best way to kind of like understand our data? So what we decided to do as a group is kind of visualize our data, since our final data set has a lot of location-based information, such as the city, state. We wanted to kind of look at where like the great sparsity of our data lies. So when you look at this map, you can kind of see that we've decided to filter our data on a couple fields. We looked at job types, since most of our data set in this aspect is federal or private. We decided to map that. The greatest density on that we can see from this map are in the states such as DC, Maryland, Virginia, or in California. We noticed that from our data set, a lot of the remote work or work that's in office usually has to do with either the government workforce or the non-government workforce. Very little hybrid work is shown in our data set, little to none, if that. So we wanted to kind of understand our data set even more. So these next couple of slides go into what we call our cost workforce management analysis. So what we see here is a bar graph, and within the bar graph, we can tell that the workforce management and financial impact factors are shown. And this really depends on what roles we're kind of showcasing. In this use case, we're filtering out on cybersecurity roles or data scientist roles. And what we've noticed is that remote roles often have comparably slightly lower salaries versus in-office roles. This can take into effect such as the space for the employee, the time that they usually spend in traffic, or other supplies that they've needed, such as like a desk or a chair. This tends to factor into what a in-office role would be for expenses. And then this also factors into what we see as commercial real estate. Since commercial real estate prices have increased over the years due to the economy, this has played a role into people that want to go into office or are required to come into office, demanding more of a higher salary. We're seeing a little bit of a more of a flexibility with remote work, but that comes at a cost of less of a higher salary. Furthermore, here's a box and whisker plot showcasing our data. What can this chart really show us? It kind of shows how sparse our data is, and then kind of showcases the median salary for a in-office or remote work job, if it's federal or private sector aspect as well. So we kind of filter down to cities or states such as California, DC, and Florida. We want to kind of show the spread or the median aspect of our data to see the outliers of the cost ratios. And we can tell that in office is more efficient based off of our data versus remote has more cost efficient costs as well. So some final insights based off of our workforce management analysis. We can tell that remote work policy should be tailored to specific cities, such as federal jobs should be factored towards the DC, Maryland, Virginia area, whereas like the private sector workforce should be tailored towards like Silicon Valley or Texas. We can see that mapping this geographically speaking kind of shows us that interior regions within our map have a little bit more budget friendly ranges for salaries for remote work versus in-office work. And then we can kind of see the highest high cost cities provide the greatest financial benefits from remote work adoption versus making them ideal candidates for hybrid work. So we can see that both private industry and federal agencies can utilize this data to develop location-based workforce strategies and enhance cost efficiency and talent retention. This way they can go out there and find the best candidate for their location as well. In the next section, we're going to talk about our methodologies. I'm going to hand it off to Mogna to discuss this aspect.
Thank you, Akash. In our project, we used a multi-method approach, combining spatial regression, machine learning, spatial analysis, and the optimization methods in order to recommend optimal hiring strategies to the companies. So we have first started with geospatial clustering, where we cluster cities based upon the hiring cost, and this visually gave us a representation of the regional cost variations and also to group the cities depending upon the cost. And next, we used spatial regression in order to model the relationship between the location-specific features and the salary. Then we used machine learning models in order to predict the hiring cost, depending upon the variables such as the city, the role, experience, and other economic indicators. And finally, we used linear programming in order to model the relationship between the variables in order to provide optimal hiring decisions depending upon the budget, such as the depending upon constraints such as the budgets. Next, we'll be delving into these models individually. So first is geospatial clustering. As I said, we have clustered cities based upon the cost, that is the hiring cost, total salaries, and we have basically used k-means clustering in order to perform this. And scikit-learn has been used for the implementation of clustering. Here you can see the map of the clusters, which basically shows 3 different clusters. This we have decided depending upon the depending upon the elbow method that we have used here, and we have divided this into 3 clusters, basically high cost, low cost, and moderate cost zones. Here in low cost regions, you can see some cities such as Western and Bridgeport. Here, the recommendation for the companies would be to hire freely, whether it is in office or remote, they can hire from these cities. And high cost zones, basically, the recommendation could be to prefer remote hiring than the in office, as the cost is much higher. And a moderate cost, it depends upon the role and the experience. The company can decide from which location to select from. So this doesn't show you the visual representation of the cities. So we have decided to develop a dashboard where you can visually see the cities across the country. So in the next slide, I'll be showing a short demo of the Tableau dashboard that we have developed. So this is the map of a country where you can see 3 different clusters, red, blue, and green, which basically says red is for high cost, green for low cost, and blue for moderate cost zones. And here we are going to select one particular high cost, for example, and you can see the red color zones, basically it's here near western and eastern part regions. And also we have the roles, we can select any role, and also the experience, whether it is entry level, mid level, or senior level. So if you select mid level, it shows the cities. And also you can go hover over the cities to see the individual details, like whether it is like it's a city details, experience, role, state, and the total in office and the remote salary. Likewise, we can make a comparison of the cities using this map. Moving on to the machine learning. So now we have saw the geospatial insights. Now we are going to predict the hiring costs depending upon the experience, role, and other economic indicators, as I said. So first we have we have done the pre-processing step where we have handled the missing values, encoded the categorical variables, and standardized the numerical features. Then we have trained multiple models like decision tree, random forest, XGBoost, and linear regression. And we have used evaluation metrics like R-square and RMSE in order to find the best model. And we have used hyperparameter tuning, like we have used grid search CV with cross-validation of 5 folds in order to obtain an optimal solution. Like here you can see very well that random forest has performed better comparatively after the tuning. So we have selected random forest, and it has been integrated into our optimization tool. And also the top influencing features. Here you can see this is from the random forest model. City, state, along with the office rent per square feet has emerged to be the most influencing factors in this particular data set. And one limitation in this machine learning model is that if user enters a city or state that is not in our training data set, it may not be able to predict it. So in order to handle this, we have used spatial regression, which will be able to overcome this failure, and it's actually a fallback model for our machine learning model. So next we'll be seeing spatial regression. Yeah, this models the variation across, as I said, it models the relationship between the salary and the other economic factors. And here we have used two methods, the standard OLS and the GWR method. And GWR is geographically weighted regression. It has proved to be the better model when compared to OLS. We're having a higher R score and a lower AIC and a residual sum of errors. Yeah. So the output of this, you can see this also shows very well that location plays a very important role in predicting, and to actually show you the difference. And location, as I said, it's a very geographical indicators is a very big influential factor in this particular project. And also overall, this GWR has given a very good prediction. So we will be using GWR in our analysis. Moving forward, next slide. It will be continued by my teammate Kirti.
Okay, thank you, Mogana. So far, we have gone through multiple models like machine learning, spatial regressions, and some other models. So now let's deep dive into the linear programming. Linear programming is one of the mathematical tools used for the cost optimization. In our case, we are using this model to minimize the total cost of the salaries of the employees while the companies are spending during hiring. So here we can see the formula on the screen, where Z represents the total cost that we need to minimize. Also here we have two decision variables. One is the office of I and the other is remote of I. These two represents that the employee can either work in office or remote, but not in both the cases. So now let's go into the demo and see how these models all together came, and we have developed the tool. Started. So the companies can choose based on their preferences in this tool. Firstly, they can select the sector to which they wanted to hire, whether it's a private sector or the federal sector. Next, they can select to the role they wanted to hire for. It may be the software developers, data analyst, or whatever the role may be. Later on, they can also select the experience level of the employee. It may be the mid and entry or the senior level. And after that, they could enter the budget, how much they're willing to spend on an employee. Finally, they can select the hiring type, whether it's a remote or an in-office. Then, later on, if they wanted to compare between the cities, they could enter the cities. For example, here we are going with the Virginia and Texas. So here we got a list of cities with a column within budget. So there we can see only some of the boxes are check marked and remaining are not check marked. So this represents those are within the preferences of the company. Then scrolling down, we could see top cost effective cities and the detailed cost comparisons of those cities. And also this tool provides the recommendations and the predictor salaries. Also the companies will have a good knowledge based to hire an employee by using this geospatial map for the US states. So now let me quickly summarize how we have started and developed this tool. Firstly, we have collected the data from various sources like OEWS, ONET, and some of the other commercial websites. After collecting the data, we have after scraping the data, we have applied we have consolidated the data and applied some of the models like machine learning, geospatial clustering, spatial analysis, and linear programming. So by using these models, we have optimized the total cost that companies would spend on the employees while hiring, and also we have created an interactive dashboard so that the companies will have visualizations for whole the US states and get easily hide the people. So for every development, there will be an improvement in the future. So in our tool, we can also add the forecasting models. So it would help the companies to adapt to those things in advance. And also this tool can be expanded to the global level so that the companies can use this tool all over the world, not just including to our state. Also, we can have a good research of how the people are having their output for in office and for remote, so that the companies can hire the people based on the productivity. At the last, we can also include the AI models to the tool so that it could work with the real-time data, so that the output should be more realistic and accurate. So thank you. And any questions?
There are no questions online, Dr. Baldo.
Take the ones online.
There are no
Oh,
online.
there are none. Okay. Any questions in the auditorium? Okay, so I have one for the team. Before COVID, we still had meetings. We had meetings in the office, and then COVID came and we were forced to work at home. And there were a number of meetings. There's a length of those meetings. And I was just wondering what your thoughts were, because now, post-COVID, there's been a desire to, there's been some decisions. Should we remain remote? Should we do part remote? As you said, hybrid doesn't seem to be working, or you don't see a lot of it. But what strikes me is the statistic or the data that shows the number of meetings, the length prior to COVID, when we were more in the office than during COVID. So I was curious what your thoughts are, what you saw with the data with respect to that.
So I can speak from like my personal experience, since I do government contracting, and I do software development. I've noticed that with my role, I work in a skiff some days, I work from home some days. There is times where before I go into the skiff that my technical lead will allow us to do like our meetings like really early in the morning, usually about 15 minutes. We keep it to like what we're currently working on, what any development is going on. This allows us to be efficient with not only the meeting, but allowing other people to get out of their house, to go onto the road and head into the skiff to avoid all the traffic. Productivity wise, I don't really know how much like the difference between being in the office or remote is. It's very subjective. As somebody who does work remote in some cases, I tend to like defend both use cases. There is times where like I am struggling with some development issues and then I need to go into the office and meet with senior leadership for like assistance on like a platform installation. So from my personal use case, I would say it's a very gray area. I've noticed that with like the climate right now, with like Doge coming in and removing jobs and requiring government employees to return to work, part of it is on their defense is to help them cut costs, cut waste, kind of prove that development's being made within that time frame. And a lot of these companies that are agreeing with the policies of Doge tend to come from that really hardcore technical FANG level background, so they kind of defend that. And we don't really know until like time passes of how much of that has affected the workforce, and how effective these cost savings are. So that would be from my personal use case. From our data, we didn't really see much of that. More of it was kind of just saying what the salary ranges are around the country based off of remote work versus in office. And then a lot of in-office remote work that in-office work that was in the local area is government-based, they tend to follow the GSA pay scale. So it's really factored on that as well. Years of experience gets factored into that. That also might factor into leadership's decisions in forcing their employees to come into office as well. I don't know if that answered your question.
No, I didn't have an answer in mind, but that was interesting what you said. I mean, some of the work that you do cannot be done at home. You have to go into the office. I'm still, and I think we need to see some data on the number of meetings, the length, because I have heard anecdotally a lot of complaints about the number of meetings, the lengths of meetings, people saying, I'm spending more time in meetings than doing the work that I have to do to accomplish that. So I'm not saying that meetings in general would be the only thing to really look at. There's lots and lots of other factors. You did mention something interesting about commute. And so I think that would be a quality of life thing, because commutes when you were showing your geospatially, you were showing the jobs. Those areas that were very concentrated, commutes can be very difficult, and that can be very stressful when you do that on a daily basis, even if you do it 3 times a week or something like that. So, yeah, I think COVID was interesting in the sense that it forced a lot of us to work remotely. And now that there's this decision to move back to the office, the questions are being asked, like what you're trying to do here is, does it make sense? Certain jobs, maybe, yes, it does make sense, but maybe there's some that we have in the 60s, they used to call this the electronic cottage. Maybe that'll work.
Well, to kind of build off of that, back in 2021, as we were returning to the office, so I used to work for the president, both presidents, Joe Biden and Trump. So the use case for me was when I was in the Pentagon with like the Joint Chiefs and stuff like that. Depending on what development needed to be done right away, kind of factored into what my senior leadership would allow us to do. So us developers would go to them and always ask, like, hey, do we need to be in this meeting? Because they're already requiring us to be on site, part of contract, part of sensitivity of the data, but also that would cut into some of our development as well. And some of the meetings, I don't want to say were pointless, but they didn't really factor into our development. So there was times where me and some of the other developers always would request working from home in those cases as well. So.
All right, we thank you. We need to stop this discussion. Dr. Rasmussen did text, said great job. So thank you, team. Okay, team AI architects, please meet me at the front.